Okay, so I worked through some examples for some basic force problems that are pretty common. First, we've got what is the weight of a 50-kilogram box? And I've always joked that this would be my one question on my one question final, and half of the folks would miss it because people always confuse weight and mass. 50 kilograms is a mass. Weight is a force, and it's going to be measured in newtons. So let's look at this. So we've got a box. It has a mass of 50 kilograms. It's got weight that's pulling it downward, and its force due to gravity is weight, and it's going to be mass times the acceleration due to gravity. And if it's sitting on a surface, it's going to have a normal force pushing back up. And so the normal force is the force that the surface applies to the box, and it's not going anywhere, it's not doing anything. So those two forces are balanced. And so this really is a real simple calculation. So to find the weight, mass times gravity, so it's going to be 50 kilograms times 9.8 meters per second squared. And so the weight is 490 newtons downward. Our next one involves not just up and down, we've got horizontal and vertical stuff going on here. So we have a cart, and it has a mass of 50 kilograms, and we've got an applied force of 100 newtons. We have a frictional force of 10 newtons. I want to know what the acceleration is. So let's look at how this works on the drawing. So we have our weight pulling down, force due to gravity, and there's a normal force pushing up, and those are balanced. And this time we have an applied force, the guy pushing on the cart, and then we have friction in the opposite direction. And so the normal force and gravitational force are equal. We're really not worrying about that direction at all. We're mostly worrying about what's the acceleration, and we know the acceleration is going to be in the direction of what's called the net force. So we have to find the net force in the x direction. So the net force in the x direction is going to be equal to that applied force of 100 newtons minus the frictional force, because it's opposing the applied force. So our F net is going to be that 100 newtons minus the 10 newtons so we end up with 90 newtons. And then if we want to know what the acceleration is, force is equal to mass times acceleration. So acceleration is going to be force over mass, which is going to be 90 newtons divided by 50 kilograms. And that is 1.8 meters per second squared. And it's going in the same direction as the cart is being pushed. So if it's being pushed to the right, acceleration is positive, and it's to the right. Okay. Last one. Rocket problem. Pretty classic. So rocket's being launched. The question is, if it has a mass of 3,000 kilograms, and we want to accelerate it at 5 meters per second squared, what sort of thrust is required? So this one is all horizontal and vertical again, like the box problem. In fact, it's all horizontal, it's all vertical. It's not horizontal like the box problem, and it's not horizontal like the cart problem. Sorry about that. So what we always have weight pushing down. Mass times gravity. And in this case, there's not really a normal force. There's a thrust pushing upwards. There's nothing side to side on this, so we don't have any wind, we don't have any air resistance, so we're just worrying about the vertical forces. And we'll set up our equation. We know our net force is equal to the thrust going up minus the weight coming down. And so this time what we know is we know that the mass of the rocket is 3,000 kilograms. We know the acceleration of the rocket is 5 meters per second squared. Acceleration due to gravity, negative 9.8 meters per second squared. We took care of that piece with that minus right there. And let's find the rest of this, our 5 meters per second. So this time we do know what our net force is. So F net is mass times acceleration, which is 3,000 kilograms times 5 meters per second squared, which is 15,000 newtons. And we can find out what the weight of it is. So that's going to be mass times the acceleration due to gravity. And that ends up being 29,400 newtons. So now we just plug it back into our net force equation, and we get 15,000 newtons is equal to whatever that thrust is minus 29,400 newtons. When you rearrange the equation, you add that 29,400 to both sides, you end up with 44,400 newtons, and that is how much thrust it takes to get that rocket to accelerate at 5 meters per second squared.